Yeah. Uh,
Good
so
morning.
guys, today we'll be starting about the Snowflake demo. So basically, I just wanted to give you a brief idea, like what is Snowflake exactly is. So before jumping into that, let me introduce myself. I am Vishnu. I'm currently working as a Snowflake architect. So basically, I started my career as a data engineer. I work with different ETL tools like ODI, Informatica, Data Stage. Also I have some idea about reporting tools like Power BI, OBI. Yeah, I think that's pretty much about me. So, okay, let me jump into the Snowflake now. So, guys, before going into the Snowflake topic, so have you got a chance to do some basic research about Snowflake? Like what is Snowflake? Why it has been becoming much popular nowadays?
Yes, sir. I just got an overview of the Snowflake.
Okay.
It is in popular because of the two things.
Mm-hmm.
I mean, the elasticity it provides,
Mm-hmm.
and moreover, the every company nowadays wanted to move to the cloud, right? So
Yeah.
whatever the elasticity and performance it provides, no other warehouse tool or which works on the cloud will provide. So that's why it is becoming famous nowadays.
Okay. Yeah. Yeah, Kishore. Did you got any chance to look into that?
No, no, Vishnu.
Okay. 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 So let us start the session. See, why Snowflake has becoming much popular nowadays is like what Viraj was saying is absolutely right. So the customers or clients they are preferring the on-cloud architecture side. See, earlier we used to have traditional databases. That is like Oracle, SQL Server, Netezza, IBM DB2. So these are all the different databases which were available earlier. Now Snowflake has becoming more popular because of its unique features. So simply what they are doing is they are picking the best features from all the available databases in the market, and they try to put in a best format way to give the best performance for the clients. Okay. So like Viraj was saying that it's a cloud database. Like what is the meaning of on-premise database? Like on-premise data warehouse. It's nothing but see in older versions they were used to install all the laptop, all the softwares they are required. Now in on cloud, they are nothing to do with that. So everything they are providing as SaaS, software as a service. Okay. So let me give a clarity on what is OLTP and OLAP. Do you have any idea what is OLTP and OLAP? Hello.
Sorry, I didn't get you. What are you saying?
OLTP and OLAP, online transaction processing and online analytical processing.
Yeah, one is used for the historical data, which was stored, regularly, and which is used for the analysis of the company for the better decision making, and other one is used for day-to-day transactions.
Yeah, you are right. So basically, what this Snowflake does is like it's providing like a SaaS service as a software. Okay, you don't need to do anything from your end. You don't need to install anything. You don't need to configure anything. Just create an account and start using it. Okay, so that's where Snowflake is a cloud data warehouse tool, and we can also call it as a semi ETL tool. Why I'm calling it a semi ETL tool, I'll be explaining in the later part now in the demo session. Okay, so right, like what ETL tool does, right? Like
Yes.
recently we have gone through that area. Like it
Right.
will
Yeah.
it will extract, transform, and loading the data. Okay,
Yeah. Hmm.
in this Snowflake there is no drag and drop mechanism. So basically we need to work only with the SQL. So that's why I was keep on mentioning that you have to keep working on the SQL skills. And nowadays, what is happening? There is a trend going on with Python. And like Kishore was mentioning the other day. So now people were getting used to the JavaScript procedures. So that's we'll look into the later part of the session. So basically, for mastering the Snowflake, you have to definitely have the SQL knowledge. I'm pretty much telling you again and again. For mastering the Snowflake, you have to have good amount of SQL knowledge. Okay. So basically in Snowflake, like we'll be, ETL part, we'll be start building the pipelines, whatever we were doing in ADF, right? So it's like not fully kind of ETL tool. It's like also acts as a semi ETL tool. Okay.
Yeah.
Okay.
Yeah.
Since it does not fully support the ETL, that's why we are using another ETL tool like ADF here.
Exactly. You're right, Vinesh.
Okay.
See, basically, you're seeing it, right? The slide. So basically, it acts as database or data warehouse and ETL tool. So this one, see in ADF, if you saw that ADF, you will be having the drag and drop mechanism, right? Here, there is nothing like that. We have to write the SQL code. Whatever to build the pipelines, to load the data, only thing we have to do is like write the SQL queries.
Okay.
Okay. Okay, let's move into the next one. See, and this is the legacy dataware architecture landscape, actually. So what they will be doing is like, so these are all the sources, different kind of sources we'll be getting the data from. And from here, we'll be extracting the data by using the ETL tool. And this is the enterprise data warehouse. Okay. So it's like a warehouse thing. And from here, we'll be segregating the data into different data marts. And from these data marts, we'll be getting the reports. Okay. Let me take an example. Like, so for DMart, we have about 100 plus stores across India. Now at the end of the day or end of the month, the CEO of the company, like he wants to know like what is the profit he got in the last month or last week. I mean, yesterday or today, like which store is performing well, which store is not performing well. What is the most selling product in the DMart, and what is the age group people who are visiting stores. You want to know answers for all this stuff. So like where will getting that answers? Absolutely here, no. So what we'll be doing is right, we'll be taking the data from all the stores and load the data into this data warehouse, right? From here, from each department wise, we'll be segregating the data here. So after this, whatever data is reported here, from here, we can be able to identify like, okay, this store is performing good. So this is the profit ratio. So you have any idea about reporting tools?
Like Power BI.
Yeah, Power BI. Okay. Power BI
Yes.
comes into picture here in this. So
Okay.
it's a business intelligence like right kind of thing, right? So basically, so whatever we extract the data, whatever we pull up the DMART data, all those data will be, we can see in a much professional way in the using the reporting tool. Okay.
Okay.
To get into more precise, like in DMART also we have different departments, right? So after loading the data, we have like HR department, marketing department, procurement department. So all this, there will be some departments data, right? So if you put all the data in this warehouse, it will look like a clumsy, right? And also for maintaining the data in one data warehouse, it's also like huge task for us to maintain. So basically, to avoid the confusion, we'll be creating a subset. These are called data marts. So in the coming classes, we'll be having much awareness of this. I will also give introduction on the like what is the data warehouse principles and concepts. So by doing that, you will be able to identify easily like how is data mart is built and what is warehouse exactly. Okay. So now as of now, don't worry. I mean, we'll be getting to detail in the coming classes. This is only I just wanted to focus on the Snowflake high level demo. Okay.
Okay.
Yeah. Okay. Now you got some idea like now where is my Snowflake will fit into this picture?
EDW
EW.
and data marts.
Okay. So I have mentioned earlier like Snowflake acts as a database and ETL.
Yeah.
So where exactly it will fit here?
And I mean, It comes under ETL, EW, and data mart, but ETL is not fully supported, right? So that's why I'm thinking it is EW and data mart.
Okay, let me clarify it. So here. So basically, I've mentioned that it is a semi-ETL tool. This is the complete picture of Snowflake.
Right.
Okay. Okay. So basically, the very first point the clients are considering Snowflake. Like, see, nowadays most of the projects in real time they are converting the projects from like Netiza, Oracle, DB2 to Snowflake. The reason only being its performance, guys. If you can compare any traditional databases, if you take Oracle, SQL Server, or Teradata, whatever available database or whatever data warehouse you take, I'm 100% sure that Snowflake is much faster than this data warehouses. Even it is faster than Hadoop in terms of performance, you see. So whatever we have done recently, one good survey, one of our client was asking like, so there is a competition between Snowflake and Azure SQL. You are having idea about Azure SQL, right? We were using in ADF.
Yes.
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 So they were asking us like, let's test and use it. Like whether they were asking us like whether we shall use Snowflake or Azure SQL. Okay, so we were asked to test it for its performance. Okay, like how much faster it is working and and all the stuff. So we tried by loading a 1 TB of data into Snowflake, and the same we have done through loading to Azure SQL. So basically, what we have found, guys, it's Snowflake is 10 times faster than Azure SQL database. You imagine it's a 10 times faster. So basically, one point I can say clearly is its performance is absolutely at its peak. So if you take like many, recently there were many projects going on Teradata. It was a pretty much very popular earlier days. Now all those clients, whoever using the Teradata, they are migrating it from Teradata to Snowflake because of its performance and its unique features.
And sir, what about the cost? Is it also cost effective?
Yeah, it's definitely. I'll be covering into the next one. Coming to the cost.
Sure.
So we have a cluster concept like the scaling up and down. I'll be covering up next topic. Yeah?
Okay.
So basically, let me give you an example here. I'll try to compare this one with Oracle. Let's consider two users are there in the database. If one user is trying to run one complex query, and the same time the other user is also running the same query. The different query. So basically, whenever the traditional database has a backlog is, if you have more number of users, the performance will be getting down. If you have any real-time experience earlier, if you observe, the administrators will use to kill the queries which are taking longer run. If you were working, you would have observed that. Okay, not a problem. But in Snowflake, that's not the case, guys. Even if 100 users, 1,000 users, or even 1 lakh users, they can work concurrently. There is no chance of performance going down. Okay, all the users, whatever I'm mentioning, can work concurrently. They can access the data. That's the beauty of Snowflake. Got it?
Yeah.
Yeah.
Okay. And one more thing, like Viraj was asking that, right? Cost effective. So for all these operations, we need compute power. Okay, I'll exactly tell you like what is compute power. But we at any point of time we can increase or decrease the compute power, which results in the costing price. Okay, I'll give a clarity in detail in coming classes. Okay, so basically we can spin up the additional clusters, we can spin down. So whenever there is no workload, when we have heavy workload, we can spin up the clusters. We can increase the compute power. This is one of the beautiful features. You are able to hear me, guys?
Yes. 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 We can.
Yeah, yeah. And the next one is simplicity. Okay, So these are all the features. Okay. Let me talk about the performance. I have mentioning that, right? The performance is pretty much high, like compared to the traditional databases. And concurrency we are talking about, right? So any number of users it can support. It does not impact anything. Like if you have n number of users working on a single query in traditional databases like Oracle, SQL Server, Netezza, their performance will be getting down. But here in Snowflake, it doesn't matter. Okay.
Okay.
Yeah, elasticity in the sense I was mentioning that, right? We can increase the server's compute power up and down at any point of time. Suppose we are having a heavy workload at this point of time, we can increase that compute power to high, and in the next couple of hours we don't have any other much heavy load. We can decrease the compute power to low. That's the problem. In legacy databases, we used to see these kind of problems more, but in Snowflake, we don't see any problem regarding to that. See, coming to the simplicity, very minimal configuration is required here, guys. To be frank, no installation is required. See, for installing the Snowflake, I mean SQL Server, you have to install all those in your systems, right? But here, we do not need any installation. We need to just get that ID password and just log into that and do our work. Okay?
Yeah.
Okay.
Yeah. Yeah. And the next one, what I'm focusing you from the last week is like SQL. You see here, right?
Yeah.
Yeah. Only we will be writing DDL queries, DQL queries, DML queries. That's it, guys. You do not have any special skills that if you have SQL as a skill, you'll definitely become a master in Snowflake.
Okay.
Of course, I mean, a little bit of Python is required because nowadays everyone is expecting Python knowledge for the data engineers, right?
Mhm.
But my suggestion to become master in SQL, then blindly you can become a master in Snowflake.
Okay.
Only thing I can say.
Sure.
And if you have Python as your additional skills, that's pretty much good. But to become master in Snowflake, I expect SQL as a, I mean, you should have SQL as a better understanding. That's what my concern is like.
So, sir, you mentioned whatever we do in Snowflake, everything will be done on, I mean, under a SQL. So we
Uh-huh.
need a SQL knowledge for that. So where exactly Python will be used here, and for what
Scripting
purpose?
points. See, for the automation, so there is some scripts going on, automation. So I'll be covering in that JavaScript procedures, Virish.
Okay, fine, fine.
Okay. So basically, what my stress again and again is like, so you have to completely have SQL knowledge. I mean, you have to understand the SQL queries. That's pretty much good as of now. So through your learning and all those, you mean, see, myself and Mahinda will be providing, I mean, some project work, right? At that point of time, we can work together. And I mean, if you have any queries regarding the how to implement and clear understanding on the all those stuff, we'll be giving you like what is the thing and what is the way we have to work in real time. Okay.
Sure.
Okay. Okay, guys. So you see, like these are the customers. I mean, they are working. Earlier, we used to have about 500. We started with 500 customers. Now, I mean, recently I did not check. Like couple of months back, this is the slide I have taken. But now I can assure that it's has crossed 10,000 customers. The clients they are using the users the Snowflake.
Yeah, even I also heard that it is growing at approximately 30% per annum.
Yeah. So I recently observed that there is a leadership change in the Snowflake side. So that
Mhm.
might boost some clients
Yes.
as well.
Yeah.
Okay. Before going, I mean, to the architecture, do you have any questions? I mean, as of now, like what we have discussed.
No, clear, Vishnu.
No, it is
Okay.
clear. Yeah.
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 So we have three. This is the Snowflake architecture, guys. Okay. please look into this. I mean, clearly, like, so we have the database storage level, the virtual warehouse level, which it's also called as a query processing level, and it's a cloud service level. This is called the brain of the Snowflake. Okay. So basically, guys, like we are loading the data into Snowflake, right? So where do you think the data is loading into Snowflake in these 3 layers?
Storage layer.
Mm-hmm. Kishore, so where do you think the data is getting stored here?
I think in the cloud services, metadata handles and transaction data, service layer.
Okay. So guys, basically Snowflake doesn't store any data of its own. Okay. It
Okay.
it uses cloud data warehouse, I mean cloud data centers, I can say. Okay. So why I'm saying that is like the Snowflake is installed on 3 platforms, cloud platforms. That is Amazon Warehouse, AWS, Microsoft Azure, and GCP. Okay. Google Cloud Platform. So basically what Snowflake, I mean, to a complete picture, it's just an application running over this cloud services. Got it?
Okay.
So what are the public cloud providers here in the market is like, I mean, you know, right? AWS is the one. I mean, the second
GCP.
is the,
GCP, Azure,
Azure, and the third one is the GCP.
Oracle, Oracle.
Yeah. Yeah, Oracle, I mean, they are coming, I mean, coming in slowly, but these 3 are capturing the market straight away right now.
Yeah.
Okay. So if you can deploy your Snowflake account in AWS, GCP, and Azure. So if you choose AWS cloud provider, then they will try to store data in S3 buckets. So while ADF, I mean integration, have you observed any S3 bucket concept in ADF class?
No,
But
block
I'm aware of
storage.
it.
Okay. Okay. We will having that integration part here, not a problem. So S3 bucket is a service of AWS storage service of AWS. Okay. It's simply a storage service of AWS. Like if you choose Azure as a cloud provider, they will try to store their data in Azure Blob.
Yeah.
Okay. And
Yes.
if you choose GCP as a backend cloud provider, they will try to store the data in GCP bucket.
Mm-hmm.
Okay.
Okay.
That means the conclusion point here I can say is Snowflake doesn't have any dedicated data center or a database to store the data, right? They are completely 100% depending on the public clouds.
So, sir,
So
I have
there
a
will be
doubt
a
here.
temporary storage, right? At least
No, no, no.
to run the transactions,
Yeah. So coming to that part,
run the queries.
tomorrow I will show you like how the Snowflake will be installed like on AWS initially, and
Okay.
how the data will be getting stored. See, basically I can say it is like an intermediate layer to get the data stored in the cloud centers. That's it. So that's why it's gaining pretty much popular. So there is no maintenance required here, guys.
Okay.
Okay. That we will discuss tomorrow, like while installing the Snowflake application, like how it has been installed on the top of cloud centers and how the work will be going on. I'll show you tomorrow in the class. Not a problem. Okay.
Sir, I have a general query here. So
Mm-hmm.
when Snowflake is using data storage of the cloud service, cloud
Yeah.
platforms.
Uh-huh.
So coming to compute layer and service layer, even those layers will be provided by the cloud
Exactly.
platforms, right?
Exactly.
So these will be used. I mean, those platforms only, the compute layer and service layer will be used uh, from the ADF or the Azure or Amazon, or will be used by the own Snowflake.
No. You are right, Viresh. Whatever, see, if you deploy your Snowflake in AWS, they will be using S3. You can
Mhm.
see here, right?
Yes, yeah,
If you deploy your Snowflake in Azure, it will be using Blob. If you
okay,
deploy your Snowflake in GCP, it will be using the cloud storage. So
okay,
basically, this is the upfront layer which we can see. but actually the data is getting stored in the on cloud centers, right? Did you got?
No, actually, I mean, the final data will be stored in the, suppose let's take an example of Azure data, Azure here.
Okay.
So whenever we using Azure, so the final data will be stored in the Azure cloud or will be
Yes.
stored in Azure cloud
Azure
only.
cloud. Azure
Okay.
cloud.
So whatever the compute and service layer will be used here, which was provided by the Azure itself, or will it be created on by Snowflake?
Okay. Let me put it that in a simple way.
Mhm.
So you were talking about Azure, right? So
Yeah.
basically it will be using the Azure blob
Mhm.
for storage.
For storage, yeah.
Okay.
Mm.
And then they will use the compute power of Azure, not Snowflake.
Okay.
So
Yeah.
what I'm trying to say is like, these are all the application part. And if you use AWS as a service, S3 bucket will come into picture here. ECD
Mhm.
node, EC2 node, that is the compute power of AWS.
Mhm.
That will
Okay.
come into picture here.
Okay.
Okay. So if you use Azure here, blob will come into picture here, and virtual warehouse of ADF will come into picture here, Azure.
Okay.
Okay.
So why
So
I'm asking this question is because when everything Snowflake is using everything from the outsource, right? So why it is? I mean, what makes it stand out as a top software?
exactly. Yeah. I'll come into the next part,
Okay,
Virish.
fine.
Okay.
Yeah,
So basically, keep in mind, they are completely 100% depending on the public clouds, guys. Just
yeah,
keep in mind that.
sure.
Okay. The second layer, like it's a virtual warehouse layer and is also called as a query processing layer. So in this layer, what we will be having is like the query, like how it will be processed. Like we will be writing an aggregate functions, some sample aggregate function. In that aggregate function, we'll be having that data to be sorted, right? Like ascending or descending order, and the process of aggregation. You know, right? Aggregate functions.
Yes.
Yes.
Okay. So that part, it will be taken care by this one, query
Virtual.
processing layer and virtual warehouse layer. Okay.
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 Mhm.
Now, okay. As Veeraj said that who is maintaining that hardware, who is maintaining this virtual warehouse? Like Snowflake doesn't maintain this virtual warehouse and it doesn't maintain this hardware. Again, I have mentioned like cloud providers will be taken care of this one. If you choose AWS as a cloud provider, they'll use ECT nodes for this query processing. If you choose Azure as a cloud provider, backend they will try to use virtual warehouse of Azure. If you choose GCP as a cloud provider, again they will use virtual warehouse of their own.
Right.
And
Got
one more thing, you can increase and you can decrease. That is what I was telling in the previous slide. Like you can scale up and scale down the resources.
it. Right.
Okay.
Oh,
At
okay.
any point of time, you can increase the hardware size, you can decrease the hardware size. So that's not an issue.
Okay.
Okay. So what makes this more thing is like, if you see these are independent to each other, like the cloud storage and the virtual warehouse. The second other thing is like the cloud service is there, right? So we have four services here: infrastructure manager, optimizer, transaction manager, security, and metadata, authentication, and access control. Okay. Now, so basically these services, as we were mentioned earlier, so whatever the AWS is looking care that the EC2 will be take care of this cloud services in this case. So,
Okay.
okay.
Mhm.
So both we call it as infrastructure, and it will get the whatever we are, suppose if you are using S3, it will be having AWS. If you are using Blob, we'll be having Azure. If we are using cloud storage, of GCP. So these will be taken care of that, whatever services. Like Viraj, we are asking, right? Like why Snowflake is required here if everything is getting from cloud and cloud services.
Yes.
Yeah.
Okay. So this from here we can distinguish like which one is using and which like cloud storage we are getting used into that. So as of now, just get into this much in your mind. In coming classes, definitely we'll be getting in detail of like why it's more required. Okay.
Sure.
So, and the next one is like optimizer. So when you run a query, let's say like, for example, simple query like select star from EMP. So someone has to look into that and get that whether the syntax or query is right or wrong, right? So for that, we'll be having an optimizer in the cloud services. Okay. And if you run a single query, if you observe that, plan will be getting created in the backend. I don't know, like if you got a chance to look into that. If you write a single query, like select star from EMP, if you in the SQL Server or Oracle, you will see a plan generating that, like how many micro partitions are out there to scan which memory location they have to scan. So for all the stuff, optimizer is used in Snowflake. Okay. Like the backend planning, the physical planning, logical planning. So these are all the stuff will be taken care by optimizer. And the next one is like metadata. So you are storing some data in the tables right here. The table level information, that means, the complete metadata column level information will be stored in the metadata. Just blindly remember that column level metadata is stored in this metadata. So why it is stored, where it is useful, you will be getting a clarity in the next classes.
For
Okay.
effective fetching the data.
Yes, exactly. That is one point. And we'll be having a cache concept. Okay.
Right.
Let me put into that. So we have wrote a query like select star from EMP. Okay, today with the same ID, like Viresh is using that with the same ID. So the next time, so what is happening, right? So you are again trying to use that select star from EMP table. So whatever metadata we are using, that it will be stored here initially, if the query is of same and unique ID. If not, what it will do is like, it will go into this data storage layer, definitely hit that cloud providers by using this compute power, and it will return the data. So what if you are having the data already with you with the same query? So what will it affect? Definitely we have a good performance issue, right?
Right. Performance, and also it reduce the cost by not using computer power again.
Exactly. So basically this concept is, the more you use, the more you pay. The
Right.
less you use, the less you pay. Okay. I got you answer, like why we are using Snowflake. So this is the one point.
Okay.
Okay. And the next one is like, security. Like any other database tools or other ETL tools, you can create users, you can give permission to certain tables. Let's say I have my sales manager. So I don't want to give him access to all other data. So what we will do is like, we'll be giving only access to the sales data. Okay. I can create a user on behalf of that. I can give that ID and password to him so that he can access only that sales data. And this one you are clear, right? Security part.
Yes.
Okay. And this authentication and access control. So basically, when you are trying to log into Snowflake, tomorrow we will be saying that you'll be having an ID and password. Okay. All those stuff will be maintained by this cloud service layer, authentication and access control.
Okay.
Somebody has to confirm that, right? You are actually the current user who are going to use the Snowflake and the cloud services.
Right.
Okay. Any question here? In this three parts, in the cloud services, virtual warehouse, data storage.
Yeah, I have a question here, sir. So
Yeah.
as you said, there is a security which Snowflake provides for the particular tables, right? For the particular user.
No, it's
So
an high level information. What security does is, it
okay.
gives, it, suppose yourself was there and Kishore is there. So you
Right.
belong to sales and Kishore belongs to HR department. Okay.
Mm-hmm.
So my concern is like, you should not view Kishore's
Yeah.
tables.
Yeah.
And my concern is Kishore should not use your tables. In some projects, there will be some requirement, because
Right.
unknowingly, some or the other things you might get into his table data and edit some data. So
Right.
that might impact the entire project. So due
Mhm.
to that eradication, the security will take care of that.
Okay. So this security will also be there in cloud platforms like
Exactly.
GCP. Okay.
Exactly. That is completely there in that part as well. But Snowflake additional has these features here.
Okay. Fine.
Okay. 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 Let's discuss the architecture. Okay. So this is the centralized database, and these are all the 4 different systems. Like, so we'll be using the Snowflake, like dev and finance department, marketing department, and we are getting the data loaded from this additional source, right?
Mhm. Yeah.
Let me put in this way. Okay. So this is the traditional architecture, guys. This is the Snowflake architecture. So we'll be discussing that shade disk and shade nothing. This is one type of policy, and this is another type of policy. So here, what exactly is shade nothing is? So we'll be discussing about the shade disk architecture. From here, this is the compute power hardware. So on this centralized database, the hardware is installed. So what is happening in this, right? If any number of users, suppose 2 users are using this, so the impact is getting highly on this centralized database, right or not?
Right. Yeah.
Right. If you see this architecture, we have databases attached to different compute power separately. So now if we have 10 users, they have assigned separate hardware. For here 10 users, they have handled separate hardware. Here also they are doing the same thing. So here there won't be any performance issue. But definitely here there will be a performance issue, guys. I mean that concurrency.
Mhm. Yeah.
Okay. In this case, you will be having more power, more performance only when you increase the hardware. Then only will having some performance issue, and there will be some limitations like you will be having only 10,000 or 1,000 input and output cycles, read cycles. So there is some limitation here, but there won't be any limitations here. Okay.
Mhm.
But
Okay.
the good point here is like, if you are maintaining the data in one place, the maintenance is very easy. Okay. But here you are replicating the data thrice.
Right.
Okay. There the maintenance is headache.
Yeah.
Okay. So my question is like, we can, even though we can increase the number of hardwares, we can improve the performance and concurrency. But why we will be using this concept? Do you have any idea, guys?
Because sometimes there will be network failures and other failures, so at that time the whole process will stop, right? So maintaining multiple copies will help us. Even if some hardware we need to fix, then we can use the same data with the different hardware with the in different locations.
Exactly, Viresh. Kishore, do you have, I mean, did you got the point right, Viresh? Kishore?
Yeah. I'm getting it.
Okay. Okay. The main motto behind is like, so these are in the real time, real time environment, we'll be calling it as data centers. Okay. So if we don't have any data stored in other data centers, imagine what Viresh was saying, that like, if any power failure or any performance issues was occurring, the system will be getting slowed down and it will be dead off. But here in this case, excuse me, if we don't see any data, getting replicated here, but it will internally switch to this one. If there is any data is getting affected here, it will definitely switch here. So in this point of time, we can 100% sure that there is no loss of data, even though there are some failures. So that's the reason why cloud providers, Snowflake, they adopt hybrid architecture. You see here, multi-cluster shared data. It's a centralized scale-out storage. The reason why they are using this hybrid architecture is they can still recover the data from the database whenever you have any issue from this one. In this case, you will be not having that scenario. Only thing is, we'll be having some maintenance cost. That is also, that's not that much. It's low maintenance cost only. Otherwise,
Okay.
if something goes wrong with this particular system, how with this particular system, how they can retrieve the data? That's a very big headache,
Right.
So basically, Snowflake. So what it will use, like it will distribute the data with this, with this process of parallelism. So to execute your query, this, performance which we are talking, right? So this is independent of whatever it is using. It might hit this one, it might hit this one, it might hit this one randomly. But in that traditional data warehouse, it definitely hit to this one only.
Okay.
Okay. Right. Okay, these are all the features, guys. Like instant speaking up, right? So this is the database and this is the different departments. And you see here, right? The warehouse. This is completely independent to each other.
Right.
Okay. That's why I'm taking, like, it's a centralized database. On top of that, you have hardware to access it.
Okay.
The greatest feature in Snowflake is the centralized database. And so that's main concern, guys. Okay. Let's say you have like different departments here, like finance users, ELT. Different department, you say analyst. Analyst will be using where come analyst comes into picture is like the reporting people. The BI guys. Again, the Power BI, what Kishore was mentioning, and the data scientists. Nowadays the machine learning algorithms. This has become pretty much popular here. So the data what we load in the data mart, it is used for the data scientists also. So,
Right.
and again, whatever data we load and test it, and for the data load to have that movement in production environment, for all those, we'll be using separate virtual warehouse. This is the compute power, guys. So it doesn't mean that this has much priority, this has low priority, this has much priority. That doesn't the case. Every department has the same and equal priority. This means that performance, there is no performance issue at all. The concurrency wise, any number of users can use it. You see here, we can use, scale multi-concurrent workloads with multi-cluster warehouses.
Right.
Okay.
Yeah. I got the clarity about the clusters here. So what exactly do you mean? Sorry, what you said? Centralized warehouse. What exactly
Database.
that means? Yeah.
Okay. See. Okay. Let me come into this architecture. Okay. If you see here, we have only database. In a simple terms, I'm explaining you. Here we will be having only one data center, right? Which is used by three hardwares. If you see here, we have three data centers and used by appropriate hardwares. The same thing you see here, we have different data centers. And from there, we have dedicated clusters running on it. So that's where I'm trying to show here.
Okay. Okay.
For each and every department, we'll be having a separate data center. From there, we'll be getting the data. So due to this process, we don't need to wait for any other performance issue and concurrency and parallelism, coming to the parallelism point of view.
Okay.
Yeah.
Yeah.
Do you have any question? Can I go to next slide?
Yes, sir. You can go.
Yeah. So see, basically in the current market, the Snowflake is planning to extend their partnership program. See, if you have these are all the ETL tools, Tableau, reporting tools, and the combination of that, Matillion, Informatica, Looker. Okay. These are all the platinum clients of them. These are all the gold clients. This is a, I mean, previous slide, guys. I mean, this one, I think there are a number of customers getting switched. So basically, what Snowflake is trying to do is like it has partnered with those ETL tools. I mean, it has built a connector internally. So why it has becoming partnership? The reason being there is a high trend of market going on with a high competition, right? Suppose in our project, we'll be using Informatica as a ETL tool, but I don't have that connector to connect to Snowflake. I have it to Oracle. So the clients, what they are looking for, like mainly in the cloud architecture. So basically, whatever, I mean, Snowflake identifies, right? Okay, this connector, we have to get into that. Okay, this much of business is running going on currently. I mean, to get into the offline terms. So this is also an ETL tool, Matillion. So this is similar to the ADF. Okay, so we have the Snowflake wants to get these connectors to them so that they can get more business.
Right, I got it.
Okay,
Mhm.
so basically what they are doing, like they are trying to get all those connectors of available tools or available technology in the market with the Snowflake. Okay. So I was discussing, right, like built-in disaster recovery and highly availability.
Right.
Okay. So basically what it's doing, guys, like we have this data available at 24/7 all time, like availability zone. You see here, this is considered as one data center and one another one, the third one. So these are called availability zone. This terminology will be you will be getting much detail in next classes, but just to see the picture as of now. So whatever data is replicating, right? So this data we can use from here, we can use from here, we can use from here. Okay. So you see, we have zero downtime here. We
Right.
don't have any downtime in the traditional, I mean, data warehouses. If you see, there will be a regular maintenance going on through, I mean, if you take Oracle or SQL Server, they'll be having some maintenance going on through administrators every now and then. The reason being to increase the patch updates and all those stuff. But here there won't be any downtime, guys. It's completely 24/7 online available for us.
Okay.
Okay. So this is also the so basically Snowflake, I mean, these clouds, I mean, come into picture in 2014, the AWS. Okay. Uh, so basically that point of time, you know, right? AWS is the, I mean, highest market grabber currently. Now
Yes.
Azure is picking up. Earlier there was, I mean, AWS time. Now Azure, I mean, guys, seriously, I'm telling, Azure will cross AWS in near 1 or 2 years. That's it. Now most projects, I mean, in our reputed companies, what they are doing is like they are removing AWS and following Azure. The reason being its simplicity and its features.
Right.
Okay. The Microsoft just came back around about 5 to 6 years only, but Azure they have actually came in, I guess, 2014. From those time onwards, it has grabbed the market. But now, I mean, Azure and GCP is slowly picking up, not that much to that extent of Azure. It's slowly picking up. So that's the reason the Snowflake guys, I mean, started thinking, okay, right, we have to partnership with these three, I mean, cloud platforms actually, AWS, I mean, GCP and Azure. Okay, now what next? Yeah, okay, let's come to the next slide. So basically, Snowflake supports structured files. I mean, you know, right? Delimited files. I mean, CSV, comma separated value files, JSON, Avro, ORC, Parquet, XML files. This is, I mean, you take another ETL tool. So this one, they have some limitations, guys. But here in Snowflake, we don't have that. So recently now they have introduced like Snowpark actually. That's a combination of Python with Snowflake. You heard the word?
Yes.
Okay. So they are started even processing the unstructured data as well. Okay.
Okay.
So, but as of now, in our class, we'll be looking on the structured data and semi-structured data, like the files process, how we will load the data. I mean, data ingestion will be happening from different sources. So from table, from this, I mean, Excel files, comma separated value files. Okay. So actually coming to the another features of Snowflake, like we can share the data, guys. I mean, suppose you have a Snowflake ID with you. Myself, I'm having an ID, Snowflake ID with me. So at any point of time, I can share the data with you, irrespective of the region. So that is called cross-region replication. And there is also another beautiful feature in Snowflake. I don't see like you will get in other one. Like it's like cloning concept. You mean you know the meaning of cloning, right?
Yes.
Yeah.
Yeah, clone the data. Suppose you have a particular table here, you can easily clone the particular table to the another reason. The reason being only because of, suppose you have the data running in production, you want to test it. So you can clone the table, I mean, as much of data you want to the dev environment.
Okay.
Okay. And another beautiful feature is like the time travel and fail safe. So what it exactly is like, suppose unaccidentally I have deleted a table here, for example, in the Snowflake. I mean, instead of writing something, I wrote a drop statement and it got deleted. So in any other traditional databases, do you have a chance of getting recovered that?
Not sure.
No, right?
No.
No.
Okay. But in this Snowflake, we can get that easily. Without the, yes, you can do it in traditional databases as well, but with the help of administrators. But here in the Snowflake, you don't need anyone's help. You can directly get that. We'll have that time travel concept is there and fail safe. So that fail safe ensures us, even though we have dropped or deleted or truncated whatever data, we can get that data.
Okay.
Okay. Right. This is the last one slide, guys. So I'm mentioning that there are a number of queries be hitting on that query compute, right? So this warehouse will have divided into multiple clusters. Viresh, you are asking about that clusters concept, right?
Right.
Like
Yeah.
how it has been divided. So you see, for each query which is running, the query scheduler is distributing the data through this virtual warehouse. So this concept and this architecture you can see nowhere.
Okay. This is the special feature of the Snowflake, right?
Snowflake, exactly.
Yeah. Okay.
Okay, this makes Snowflake uses, I mean, excellently in the backend as well as in production. See, basically, I've worked with Oracle like about 5 to 6 years, and I've been associated with Snowflake for about a couple of years, I guess. So basically, I observed that while using Oracle, we used to face minimum 3 to 4 problems a week, every week. The reason being it's downtime. But when we migrated to Snowflake, we were not using a single issue. See, the simple reason is like the maintenance of the hardware and this compute power and all those will be taken care by backend cloud providers.
Right, because
Okay.
they are much reliable. So
Yeah,
even Snowflake become much reliable on top of
reliable.
that. Yeah.
Okay. Due to that only, Snowflake is becoming a master and the leader in the market currently. And you can see that in nearby future, Snowflake will be coming like a boom.
Mhm.
Yes,
Yeah.
I can guarantee that. So we have I mean, this concept also in Azure, the data warehouse, Synapse. But you can
Yes.
observe, yeah, you can observe that instead of using the Synapse as well, some projects, not many projects, I should say, some projects, they are preferring Snowflake over Synapse. Okay.
Okay.
Only those Microsoft, I mean, customers. So, see, they will be having a rule. Basically, if you take this, I mean, ADF, you have to definitely use this over Synapse. So, their projects, they are not using that, but the Snowflake guys, they are using it as a, I mean, multi-environment level. It can be used by anyone. So that's what I'm. So like, I completely say that the third party application you said, you can say.
Okay.
Okay. Okay. I think, guys, that's it from my end. I mean, we'll talk much detail in tomorrow's class. So basically, we'll go through that installation part, and we'll get into that. So before winding up, do you have any questions? And one more thing, guys, please listen to me. I'm stressfully again and again. Why I'm saying is like SQL is plays a crucial role here. SQL is
Mhm.
pretty much important for you guys. If you know SQL, it's like cakewalk for you. Snowflake is nothing. It's. I mean, see, Snowflake is. I can say it's nothing of you. I mean, if you can just focus on that little bit, Snowflake is nothing. But my intention, my focus will be on you guys need to understand the Snowflake queries.
Right.
Only that help I need from your end.
Sure, sir.
Okay.
Fine.
Yeah.
Yeah. Let me know if you have any questions. I mean, we can wind it up. Initially, we'll be having like we'll be taking a 1 hour class. Once you pick up the pace, we'll be moving ahead. Okay, as discussed. The
Yeah.
timelines which we have discussed, that I don't want to break it up. We'll be trying to close it. I mean, whatever we have discussed earlier.
Sure.
Till now clear.